In this podcast, we're going to talk about Henry's Law. The amount of gas dissolved in a solution is proportional to the partial pressure of that gas above the solution. If there is a lot of gas in the air above the solution, more of that gas will be able to be dissolved in solution. This explains why a 2-liter bottle of soda releases a lot of gas as you open it, because you're relieving the pressure and the amount of carbon dioxide above the solution. Here's an example of how Henry's Law works. In the beaker on the left, there is a lot of carbon dioxide above the solution. This leads to more carbon dioxide dissolved in solution. On the right side, we have less carbon dioxide above the solution, which leads to less carbon dioxide being dissolved in solution. The one on the left represents a closed bottle of soda. The one on the right is what happens after you open the bottle of soda. Hence the reason why the carbon dioxide comes out of solution and starts bubbling up towards the top. There's a specific formula for Henry's Law, but in this class we're just going to compare the solubility compared to the partial pressure, and we'll be able to figure out some results using this formula here. For example, if 0.85 grams of a gas with a partial pressure of 4 atmospheres of pressure dissolves in 1.0 liters of water at 25 degrees Celsius, how much will dissolve in 2 liters of water with a partial pressure of 1.0 atmospheres of pressure and the same temperature? So the first thing I notice is that the pressure is going from a high pressure to a low pressure, so we should get less gas dissolved in solution. So let's start filling in the equation. We have 0.85 grams of gas with a partial pressure of 4 atmospheres, and it's dissolved in 1 liter, so the solubility at that pressure is 0.85 grams in 1 liter. So I write that out as the solubility there. The pressure that was able to be dissolved is 4 atmospheres. Now we are taking that pressure from 4 atmospheres of pressure to 1 atmosphere of pressure. So we can use cross multiplying and dividing to figure out the solubility of the second situation. And we find out that the solubility is 0.21 grams per liter. But remember that we wanted to see how many grams of this gas could be dissolved into 2 liters of water. Well, if we can get 0.21 grams dissolved into 1 liter, if we multiply that by 2, we'll find out we can get 0.42 grams of gas dissolved in 2 liters.